Hey, welcome back to FemMama Physics. In this video, we're going to talk about rational numbers. This is a new unit. In fact, our first unit. And, which means, lots of new stuff. Okay, let's get started. And as promised, what I do in the beginning of every video is I introduce a board game in which I try to pick one that is related to kind of what this video is about. Today we're going to be looking at Terraforming Mars and how this may be related to what we're talking about, rational numbers today. So let's get started. And I'm going to have to go over to this phone to show you the rest of this board. So let's get started. All right, so board game is backwards. So here it is. Here's the cover, Terraforming Mars, one of my husband and I's favorite board game that we own. It's ranked very high on Board Game Geek, about one of the top 10s. And it's got a lot of interesting science themes in it, which we love as well. Here you go. Here is the entire board. There are expansions, so this is not the only board, but essentially you see a big circle in the middle. That is Mars. And there's all these components in the game over here. There's a lot of cards, which explains all the deck boxes to the back. I had a few set up here. I could show us later what that means. So essentially, the game here is about terraforming Mars. Terraforming Mars in different kinds of ways. One of the ways is to raise the temperature. Of course, we need the temperature warmer than negative 30 degrees Celsius, which is our first reference to rational numbers. Every time students come in every year, I find that the concept of the negative numbers needs a little bit of work. So here's a good example of the idea of what a negative number could represent. So temperature is a great one. Normally we're used to something above 0 degrees Celsius. Anything lower than 0 becomes colder and colder and colder. But let's say we start off at negative 30, we have to start raising the temperature from here. Every time we increase the temperature, we become less and less negative until we reach 0. And after we become warmer from 0, the number becomes more positive, and notice the number gets larger and larger from there. Oh, whoopsie, camera was out of there. Okay, so that's the idea of the temperature as an example. It's the negative and the positive are all relative to a reference point of 0. So it really depends on what this reference point is. In science, we set the reference point to be the freezing point of water, which can be anything, and anything relative to that 0 is going to be colder, which goes into the negative, and warmer into the positive. In fact, if you're interested, you can take a look at something called the Kelvin scale, which is based off of temperature as well, but it uses a different reference point. For example, 0 degrees Celsius in kelvins is about 273 kelvins, and the absolute coldest temperature in the Kelvin scale is 0. So which is, in Celsius, negative 273. If you're interested, you can look more into that. But the idea of the negatives, the idea of negative numbers, all depends on where that reference point is. So that's one way to terraform Mars, is to increase the temperature using different cards that I'll show you in a second. The other way to terraform Mars is increase the oxygen rating. So we want the oxygen to go all the way up to 14%. On Earth is about 20%, and we need that to be habitable for that so increasing temperature. The other one is to, these are ocean tiles, meaning we need to place these ocean tiles onto the board itself to help terraform Mars. So once all these trackers go up to the max, and all the ocean tiles are all used up, we have completely terraformed Mars. That marks the end of the game. Every time you terraform Mars, you get a nice terraforming rating that looks like this little orange symbol, and you go up on this track every time you terraform Mars, and they get directly converted to victory points at the end of the game. So the more work you do contributing to terraforming Mars, the better you'll probably do by the end. So how do you do all these terraforming actions depends on the cards that you're able to buy and play, which they might do certain things as well as give you different kinds of resources. So here we got a few things we can talk about, and again, rational numbers can come into play. Oh, and I forgot about this one. 14%. Hey, 14% is also part of rational numbers, which we can talk about because guess what? A percentage is not only a percentage, but can be represented as a decimal and a fraction. All right, so sorry about that. Let's come back here again to our resources. Notice that each of our resources has different kinds of things that it will give you in terms of income at the beginning of every round. And so for example here, it's got -2. This 2 here is your income. And here's my tracker of all my resources that I would get at the beginning of the round. So I would have to take this and move it down 2 steps. It's hard to do that with the camera. And hey, there's another idea of a rational number. We're going into the negative region again. So that means that I have to take away 2 income every term. I have to pay $2 million to sustain this lunar beam thing that it's anyways, this card essentially. But so yes, I would be $2 in debt every single round. But the nice thing about my income is that I also get to add my Terraform rating points, which is 20 at the beginning of the game. 20 minus 2 gives me a total of 18 income at the start of every round. So that would look like this. Oh, and then here's my resource tracker. Every bronze is 1, silver is 5, and gold is 10. So then that's what I get at the beginning of every round, assuming this card here is in effect. Okay, and also I get 2 of these, which represent thermal. So I get 2 thermal energy at the beginning of every round and 2 electricity production every round. So it will look like this. And so at the beginning of every turn, I would do this. Okay. Interesting thing here is if you don't use your electricity tokens or your resources, they get converted into thermal energy at the end of the round. So I thought that was neat in terms of the science in this game. Okay, so that's the so there again another reference to the negatives. Okay. Oh. And just for those of you who like engine building or just even online engine building video games, here's an interesting engine that not that always happens, but anyways, it's to generate these microbes. So every time I play something, I generate a microbe, and then on this card, this one gets to suck the microbe over here. So then notice here I have a nicer microbe to point ratio. What this means is that at the end of the game, every 2 microbes gives me 1 point. This card is every 3 microbes give me 1 point. So here is a ratio. Again, another rational number here that we can refer to. Every ratio can be represented as a fraction. Of course, this fraction is nicer because every microbe that I get is going to generate me half a point. Every microbe here is going to generate me 0.33 repeated points, which of course this one is better. So if my ants eat my decomposers, then I get more points at the end of the game. Cool, huh? So engine building for the win. One of our favorite games, Terraforming Mars. So let's come back to math and rational numbers. Time to pack this game away. All right, and we are back. Thank you for joining in on that one. In fact, I probably will break this video lesson down into 3 parts just to make sure every part is short and not too long. So what I'll do is I'll probably get to about here, and then I'll mark the next video with that. Okay, so we're going to talk about rational numbers, giving us a better sense of what rational numbers are. What is a rational number? I think it's easier just to look at examples. So let's talk about what are rational numbers, what aren't rational numbers. A rational number can be written as a fraction. So all of these numbers that you have seen before, these guys over here, these are all rational numbers. And it doesn't matter if they're negatives or positives, they are all rational numbers. Your rational numbers can be fractions, it can be whole numbers. So, for example, this one over here, this is interesting because you have it as a fraction, but technically it is a whole number. Because if you think about a fraction really is this line in between here. That just means to divide. So, in fact, this one is -8 divided by 4, which is going to give us 2 or -2. In fact, that's going to give us the same thing. Because if you take 8 divided by -4, you're also going to get -2. Okay, So that's going back to rules hopefully you've learned before. So if you remember, if you take two numbers, you multiply or divide them. Two positive gives you a positive, negative and a positive, doesn't matter the order, it's going to give you a negative. Two negatives are going to give you a positive. I know what you're thinking. Two negatives don't make a right, but only in math, okay? I wish I could say that with more rhyme into it, but anyways, that's the concept there. All right, so yes, of course. So anytime you have a whole number that's, for example, 3, you can write it as 3 over 1, because that always will give you the number itself. Anything divided by 1 is going to be itself anyways. So that's another example of a rational number. It's almost as if over here we're trying to refresh you on a few of the old few things you've learned before to with the idea of the rational numbers. Okay, here is another example. Mixed numbers, improper fractions. This one should say 4 instead of a 3. So maybe correct that on your sheet if that's still the case. Any sort of mixed numbers or improper fractions, they are also rational numbers. And here I have an example where you're converting between a mixed number and an improper fraction, which I will do an example. Actually, I'll do it right now. How to convert between mixed number and improper fraction. Hopefully you learned this before, but as a refresher, this is how you do it. This is 3. Think of this whole number, this number, as 3 whole objects, pizzas, apples, whatever it is, and another quarter of it. So if you think about it, it's actually just 3 plus a quarter. That 3 in front is just representing the whole number, and then the fraction is just whatever is left over. So that is 3 and a quarter. If I have to put this on my calculator, I could also do it this way. So let's go here. This is essentially 3 plus a quarter. So if I take 1 divided by 4 on my calculator, that's going to give me 1 quarter. And in decimal, that is 0.25. Anytime you have a fraction, convert it to a decimal, take the top, divided by bottom, gives you our decimal. So 0.25 plus 3, this is going to be my decimal. 3.25, which is this guy over here. So your mixed number is really just two things added together. And to convert it to an improper fraction means that you kind of combine the two together into the entire fraction. Sometimes your numerator might be bigger than your denominator. To do that, you take the 3, you multiply by the 4, okay? 3 times 4 here, so you multiply this one, and you add the numerator on the top, plus 1. You keep the denominator the same. So then, what's 3 times 4? 12. 12 plus 1 equals to 13 over 4. Okay? So 13 over 4 is also, if I want to do this on my calculator, it's also going to give me 3.25 without mistake. Okay? Assuming that you did the math correctly. Okay, so there you go. That's an example of another rational number, is that one. In fact, for the majority of this course, later on, especially when we do algebra and some of the other units, I almost prefer you leave your answer in proper fraction form because it is more practical and you can take that number and do so many more things with it. Rational numbers can be any fraction that is it can be terminating, or if it has any sort of repeated decimals. So a good example of that is 1 over 3, which we know is going to give us 0.3333333. So if it's a repeating decimal, then this also is a rational number. Here in our example here, we have 10 over 3. So if we take 10 divided by 3, this gives us 3.33333. And don't forget, there is a negative sign in front. Anytime there's a repeated decimal, you would put a bar on top of the number that is repeating. And if it's just a 3, you just put the bar over 3 like this one. Next up, we have 3 divided by 7. 3 divided by 7 gives us, ooh, that looks a lot of numbers here. 428571. 428571. 428571. So I could keep writing this repeated decimal, or I can just write a bar on top of all the numbers that would repeat themselves again. And last but not least, I have 2 1/4, or 9/4. That one seems like it's going to terminate. But let's just double check here. 2.25. Don't forget it's negative, so negative 2.25. And of course, it's terminating. So it's a terminating decimal. For sure, it's a rational number. So all in all, in summary, your rational numbers include integers, positive and negative fractions, positive and negative mixed numbers, repeating or terminating fractions that can be negative or positive, okay? Now, then you might be thinking, well, that means everything is a rational number, right? Then what are these irrational numbers? Irrational numbers are fractions or any sort of number that does not terminate, does not repeat. There's no set pattern to the decimals that follow afterwards. For example, pi is a good example. It does not terminate, it just keeps on repeating itself. Challenge for you from short personal story for you. When I was younger, my mom could memorize the digits of the decimals of pi to about 30 decimal places. So I was jealous, and I was just the rebellious kid. I want to be able to memorize more than my mom. So I memorized how many more? About 10 or 12 more digits than she did. It's like, yes, I can memorize more than my mom. Then I met a friend who could memorize pi to about 400, if not, I think 1,000. I think a lot more than digits of pi. He is crazy. So, yes, the decimal does not terminate in pi. And I think there's people who can memorize. Anyways, tens of thousands of digits, but... Anyhow, not that it's anyways. Next up, I have square root of 2. So perhaps you've learned about the squares and square roots last year. So what does that look like on the calculator? It would look like this little symbol here. Okay, so if I took 2 and I pressed that, it gives me 1.414213, etc. over here. Notice there is no set pattern. None of these decimals repeats. So since it does not repeat, these are your irrational numbers. Okay, so hopefully you have a little bit of a sense of what your rational numbers and irrational numbers are. Rational numbers are nice numbers. Irrational numbers aren't so nice. There's nothing you can do to really be able to find a pattern to them. Okay, so that's kind of the gist. So now that you have a little bit of idea what are rational, irrational numbers, the rest of the lessons will talk about giving you more sense to what decimals and comparing decimals and fractions, comparing negative decimals and fractions. Okay, so that's the idea. So thank you for watching part 1. See you next time on part 2 of Rational Numbers. Fan Mama Physics signing out.